Have you ever thought that the light we see every day is actually not the same? Why do colors look different under sunlight than under lamplight? This episode traces the evolution of light sources and see how humanity, step by step, managed to bring sunlight indoors. The original light source was nature's gift, the sun. In ancient times, humans could only rely on daylight, rising with the sun and resting at dusk. But sunlight is limited by day and night, and by weather. It cannot be used at any time. So, in order to see clearly in the dark, humans began to make their own light. The earliest man-made light source that humans mastered was fire. Campfires, torches, burning wood, humanity's first self-made light. Burning fuel releases heat, which radiates visible light, thermal radiation. But open flames have limited temperatures. The light is heavily red and yellow shifted, with almost no glow. Most of the energy becomes heat. Only a tiny fraction turns into light. Still, it laid the dawn of civilization. Later, humans made candles and kerosene lamps, more stable and portable. The principle remained the same. Thermal radiation, and the spectrum was still biased toward red and yellow. But at last, people could see clearly indoors. And so it remained for over 1,000 years. Electricity brought a revolution. Edison's tungsten filament incandescent lamp ushered in the era of electric lighting. The principle was the same. Thermal radiation, but far hotter, 2000 to 30 degrees Celsius. The spectrum is a smooth, continuous curve, giving a soft light. However, over 95% of the electrical energy turned into heat, with less than 5% becoming light. The incandescent bulbs were inefficient and short-lived. It was phased out, while incandescent lamps lit up the night. A more fundamental question kept puzzling scientists. What exactly is light? In 1666, Newton made history with an experiment. He drilled a hole in a shutter, let sunlight into a dark room, and caught it with a prism. A miracle appeared on the opposite wall. A rainbow-like band of red, orange, yellow, green, blue, indigo, and violet. This is the famous Newton's dispersion experiment. It proved for the first time that white light is not pure, but is composed of many colors mixed together. Between these colors lie countless hues, a continuous transition from red to violet. This is the spectrum of sunlight, covering a continuous range from ultraviolet to infrared. Newton had split light with a prism, but after splitting it, could we precisely read each component? Newton opened the door, but the spectrometer let us read its composition. In 1814, the German optical master, Joseph von Fraunhofer, discovered that the solar spectrum was crossed by hundreds of dark lines, the Fraunhofer lines. In 1859, Bunsen and Kirchhoff built the first usable spectrometer. They found that each element has its own unique spectral fingerprint. With the spectrometer, humanity could finally read exactly what was hidden in light. Armed with this tool, we can now look back at man-made light sources. What do their spectral fingerprints look like? Back to the timeline, incandescent bulbs wasted power, so scientists sought new principles. In 1926, Edmund Germer built the first usable fluorescent lamp, the daylight lamp. Mercury vapor emits UV, which excites phosphor to produce visible light. But viewed with a spectrometer, Mercury's spectrum shows sharp peaks, especially in the blue. The spectrum has sharp peaks, not a smooth curve tiring for eyes. energy efficient, but eventually replaced. From Newton's splitting light with a prism to Bunsen and Kirchhoff reading the composition of light with a spectrometer, it took nearly 200 years for humanity to finally see every component of light with precision. But seeing light was not the end. A grander question arose. Since we can split it, could we go the other way? Reassemble different colors to create any light we want? The answer to this question begins with the human eye. The various colors we perceive can be produced by mixing the three primary colors, red, green, and blue, in different proportions. This is the RGB trichromatic principle. Red LEDs were already available in 1962, and green LEDs followed soon after. But blue was the hardest. In 1993, Shuji Nakamura made a high-brightness blue LED. The invention of the blue LED completed the RGB trio, and white LEDs finally became a reality. In 2014, Nakamura, Agasaki, and Amano shared a Nobel Prize in physics. More importantly, for the first time, we had a choice. But the story does not end there. What does choice mean? Light is no longer what you get, but what you create. In agriculture, humans have learned to feed plants with specific spectra. Red light promotes flowering and fruiting, while blue light helps leaves grow. In plant factories, without sunlight, vegetables can still be harvested all year round. In health, we cut harmful blue bands to protect eyes, and use UV to disinfect wounds and sterilize water. In industry, UV light instantly cures coatings and inks. Mobile phones, furniture, and print all rely on this invisible light. In scientific research, humanity has gone even further. Sunlight has two inherent flaws: uncontrollable and unrepeatable. Clouds, rain, seasons, and day-night cycles all alter the spectrum. Scientists don't need light. Brought indoors, they need light. Replicated in the lab. Thus, the solar simulator was born. It freezes sunlight in the lab, overcoming three challenges: spectral matching, spatial uniformity, and temporal stability. It supports PV cell certification, aging tests, and photochemistry research. From farms to factories, from eyes to the lab, light is no longer merely a gift of nature, but a tool in human hands. Looking back on humanity's journey with light, Newton split white light with a prism and revealed its composition. Bunsen and Kirchhoff read the spectral fingerprints of light with a spectrometer. Centuries later, RGB colors let us reassemble hues and synthesize. From splitting to reassembling, humanity has completed the cognitive loop of light. From campfires to simulators, we've walked a 10,000-year path, and the destination of this path is to make light serve the well-being of humanity. Next episode, another identity of light. What is it? Scientists have debated that for 300 years. Stay tuned. See you next time.